mao ni imong theoretical discharge. Okay? Whereas ang imong actual discharge is katong makuha nimo ani nga experiment. Katong experiment number 5 katong gi-explain na ninyo last time. Katong pag-discuss nato sa chapter 5, di ba nag-discuss ko ani nga experiment number 5. So ingat to. Or katong venturimeter, katong sa midterm nga kuan, midterm nato. So this is kanang how to measure the discharge. So ang imo makuha is mga Q actual. Okay, sa kani nga mga devices. So kani pod Q actual. Kay nganong Q actual man, that is the actual discharge nga imong makuha sa imong actual nga system. Whereas kani is in theory, mao na imong makuha. So unsay kalahian nila? So sa theoretical discharge kani, you do not consider the head loss. Okay? Wa kay head loss sa theoretical discharge. I mean, ani nga sa theoretical discharge. Whereas sa actual discharge, ang imong makompute na nga discharge diha is giminusan naman sa head loss. So meaning, mas gamay jud ni. It will be always lower. So that would mean that the actual discharge over theoretical discharge should be less than 1. Mao jud na kanunay. Okay? So it should be less than 1. Mao to sa katuin yung gi-answer nga CD which is equal to 0.98. So kuha na to kanang murag hapit na to sa correct nga answer pero tungod dagi kay nagamit mo ang CD, inyo nang gi-consider ang kuan ang head loss. So kato sa chapter 5 kay we are not considering head loss pa man. So the actual discharge may be accomplished by series of observations, usually by measuring the total amount of fluid passing through the device for a known period of time. So mao ni siya. Whereas the theoretical value can be accomplished using the Bernoulli's theorem, neglecting losses. So unsa man pod ang coefficient of velocity? So ang coefficient of the velocity, it is the actual mean velocity to the ideal or theoretical which would occur without any losses. So meaning kani against actual gihapon kaning velocity. So mo na yung katong makuha nimo sa katong equation nga katong gi-discuss last time nga y is equal to x tangent theta minus gx squared over 2v actual cosine squared theta. Kani nga equation. So ang VA ani so kani actual velocity na. Okay? So unsa may kalahian sa actual ug sa theoretical? Naturally, ang theoretical velocity is katong sa equation nga square root of 2g h or katong v squared is equal to sayo. Or katong equal sa katong sa kinetic energy. So di ba h is equal to v squared over 2g. So kani that is the velocity theoretical. So kung imo na siyang i-rewrite, mao na ning mahug nga ingani. Okay? So mao ni. So mao nang pagkuha nimo sa velocity actual velocity. So this is the actual mean velocity. Nganong mean man? Nganong mean man jud na? So the average velocity. Kay ngano man, for example sa hose, naka-hose sa tubig, di ba? Inig-agas nimo in this time kung ato kanang pag-agas na dili na ni sila equal ang velocity sa pag-agas. For example, ang kaning velocity diri nga part is not equal to the velocity diri nga part. But we take the average. So mo nang gitawag nato nga actual mean velocity. So mo na sa kay remember when we discuss chapter 5, we must have to have an ideal fluid. Pero in reality, wa man kay ideal fluid. Okay? So in reality, wa kay ideal fluid. Pero sa kaning mga problem solving na to, we are considering na ideal sila. So that's why nahug sila nga theoretical nga velocity. So mao ni siya kani mao ni ang imong equation sa theoretical velocity. Kani makuha nimo sa actual velocity. In this kuan kani is katong sa figure nga kung imong may maklaro katong sa kani pag maklaro sa yellow. So kung mao ni imong kuan dira na host mao ni so kani this is your x and this is your y. So kay ubos man siya sa orifice mo na nga ang imong value sa y will be negative. So don't worry kay ang imong answer ni will be positive. So kay bale kung kita ato ni nga 2 meters ni ang imo i-substitute dire is negative 2 because this will be your datum kani dire mao ni imong datum. So ang ubos ana ni dia negative, di ba? Kay bali mo man imong x-axis. So ang ubos ana tanan negative. So man mao man imong y dire axis. So positive imong value sa x. So mao na. Kaning angle nga theta, that is the angle sa imong for example in this kuan is orifice. So na may times nga ingani ang porma. So if this is your orifice, kibalingan ang tangke. So may nga ang tubig. So kani siya dire kani mao na imong theta. So mao na imong theta dire. So kung inclined ang imong orifice, so mao na nga times na kay theta. So coefficient of contraction mo ni siya. So kabantay mo if this is the diameter, if this is the diameter kani mo ni mo diameter, kabantay mo nga ang kani nga redepita is gamay na siya. Di ba? It's because it depends upon the opening. So mas kuha na imong opening, so mas gamay ang imong value sa imong CC. For example, ani, if it is a thick plate or rounded plate, ang imong kay diri pala man daan sa opening imo naman si Jangi pagamay, so inigawas na ni mo equal na ni si dire. So mo na mahitabo. So mo na nga ang CC sa rounded o sa thick plate is 1. So naroon ni sa libro sa gilisan niya. So for instance, it is sharp edge or square shoulder na kay value sa CC. What is CC? That is area of the gem. So in some cases it will be said nga area of the vena contracta. So yan na. So area of the vena contracta and kani is area of the opening. Pwede ba yun nga area of the nozzle or area of the orifice? So kana. So it is the ratio between the area of the vena contracta or area of the jet over the area of the opening. So mo ni. So it can be equal to 1 but it cannot be greater than 1. So ingana na siya. Okay. So the relationship between the three coefficients, so from the formula nga actual area times actual velocity, so kani makuha nimo nga C is equal to CC times CV. So okay. Mao to. So nakay tulo ka coefficients, device coefficients C or CD, then CV and CC. So coefficient of discharge, coefficient of velocity, and coefficient of contraction. So again, there is a relationship between the three, which is the coefficient of discharge is equal to the coefficient of contraction times the coefficient of velocity. So naka-given nga ni pero usually given man ang unsa ni tawag na coefficient of discharge or kundi mo ipapangita. So there's no need to memorize the table. So there's a head loss with respect to CV and velocity. Remember that ang head loss nimo nahitabo kay tungod sa nanakay flow sa imong tubig. Therefore, the formula for the head loss is due to the velocity. So take note that the actual velocity here is the actual velocity. So it is the coefficient of velocity. So 1 over cv squared minus 1 times the quantity of v squared over 2g. So remember that this value here is also equal to the head. Okay? So, muna sa kung tayo na kay head, pwede na nagmuna na yung gamiton. Velocity head. So, meaning pwede nimo ma-substitute ang value sa 8q squared over pi squared gd to the fourth diha. Kay equal naman na sila. So, okay, first na device na to is orifice. So, what is an orifice? It is a small opening. So, usually circular, but not necessarily nga circle siya na square, triangular, etc. etc. So kasagaran lang kay circular siya to maximize the area at the same time to lessen the friction at the opening. Dili friction ka ng losses at the opening. Okay, there will be larger losses if there is a sharp edge. So mo na nga i-circular na kasagaran. So, okay. So, unta example sa mga orifice. So ang mata na na orifice kana mo gawas ang kuan luha. So kana small opening basta small opening na siya. Okay. So for the orifice mao ra ni ang imo mga equation. So no need to memorize kay actually that is still Q is equal to C A V. Mao ra na siya. Kani hibaw man ka nga ang unsa tong theoretical velocity. Diba? Theoretical velocity katong giingon ninyo ganina is 2gh. Area ni sa orifice kana kay naman kay C dire. So remember nga mahimo ng Q is equal to CC CV AO VT. Kay ngano man kaning CCAO mao na imong actual. I mean dili actual kanang area of the jet. And ang kaning CV o VT, that is your actual velocity. So, ang makuha nimo ana is ang Q actual. Okay? So, if wa ning C, if katurang Q is equal to AV, di ba? Theoretical na siya. So, kung imo na siya kuan, so this means, it means nga kani is velocity nga theoretical o kani is area of the opening or the orifice. So, mora na siya. So, mora ni nga ang katong equation nga ato na ibawaan sa suganan, mora na siya. Imo rang gi-substitute ang V nga square of 2gh. So, imo rang gi-rewrite ang equation. So, imo rang tanawa ang kung imong bubantayan ang theoretical velocity square of 2gh. Ang actual velocity butangan na ng CV para ma-actual. So mora na yung kalayan nila. Theoretical discharge area times velocity, di ba? Kay velocity man area times velocity, theoretical discharge. Actual butangan na nimo C, di ba? So CA squared of 2G. So ang H nimo ana is equal to H plus kani VA squared over 2G plus PA minus PB over gamma. So that is the H. So sa ning H, this is your H. So values for H in various conditions. So kaning capital H. So H will be H if your pressure is equal to 0. If naka-acceleration upwards, remember sa katong chapter 4, so naka 1 plus minus A over G. If naka-pressure dira, so katong katunan sa chapter 2, if this is closed tank, so P over gamma. If it is closed tank and has multiple layers of fluids, then you add the what do you call that? The head. So, mara na siya. So, submerged orifice, there's a difference between the head. So, na kay upstream, na kay downstream. So, the difference of the head, mo na imong H na gamiton. So, your capital H is equal to H sub 1 minus H sub 2. So, contraction of the jet. So, okay na na, orifice of lower head. Okay, so, okay, nozzle, same ra. Area of the nozzle, ray, kalayan. So, Python tube. So, name after the French physicist and engineer. So, Henry Python. So, kani, ang kalahian ni just sa piezometer, if you look into this one, the piezometer is kaning A. This is your piezometer. Okay? Katong sa chapter 2 nga itong nakatunan. So, piezometer, if you remember, it only measures P over gamma or the pressure head. Diba? It only measures pressure head. Look at the Python tube. It measures pressure head plus velocity head. So, mo na siya. Okay? So, mo na ni. Mara ng kalahian nilang duha. So, this is your EGL, this is your HGL. If there's a distance traveled, di na sila equal. Tanawang A ug sa C, di na sila equal na nakay head loss. Okay? So, kanang kay nagbali naman siya, di ni siya ma-compute ang unsa na ang velocity, so mo nang mas gamay siya dire. So, meaning against the flow siya. So, here you have a Python tube in the pipe. So, makuha nimo, ma-determine nimo dire, ma-appeal nimo ang velocity. So, gates, di na. Okay, so steady. Okay, so sa unsteady flow, murag duha ra ka topics sa fluid mechanics nga i-consider nimo ang as hydraulics nga unsteady dili sa orifice ug sa wears. So after ani nga topic wears man, so if you look closely, if this is your tank, so there's a different elevation already. As the flow continues, as the discharge continues to flow out from the tank, and ato inaon nga wa kay Q in, so ang imong level sa water dire is mo padong ubos, di ba? If ang katong sa steady flow or constant head, mura kasagaran na is constant head man. So mahug na siya nga constant head kay tungod ang imong Q in is equal to Q out. Okay? So mo na atong trabaho on sa chapter experiment number 6. So maybe by April 6 magsugod na ta sa mag-send ra ko sa inyong mga schedule. So sa experiment number 6, constant head ato i-consider. So dapat ang imong Q in must be equal to Q out. Okay, so mo na ang kuan. So meaning your head will not change. Kaya kung unsa na tumusod diri mo ra may mugawas. If mas dako na ang mugawas kaysa musod, meaning mo naman siya kaubos. Pero if mas dako ang musod kaysa mugawas, mo naman nig saka. So di ba nga naman na. So dire ang makuha nimo sa kasagaran na ni is with this the time value, because you need to determine the time, the amount of time in order to lower the head from point 1 to ato yung nga point 2. So that means that there is a change in the volume. So, di ba? So, dV is equal to Q in minus Q out dt. So, if we rearrange this one, it will become dV over Q in Q out. So, we take the derivative. So, it will become dt is equal to AS. So, times dH. So, your AS there will become constant because what is varied in this is the head. So, Q in, Q out is the same. So, mo na nga, if we take the integral, para makuha na to ang time, so from H1 to H2, ASDH, Q in, Q out. So, nga na lang na siya. So, there's a formula for constant cross-section. Kani, if constant ang cross-section sa imong tank, pero if di ganin siya constant ang cross-section, kani din imong gamiton. Okay? Or kani, depende. Okay, if this is kuan kung wa kay Q in, so kanina may mo gamiton. So again, if it is constant. Kay there are times na dili constant. For example, your tank is a frustum. Nga na. Di ba mo naman na mo kagamay ang imong mo naman ang kagamay imong cross section or maski mo yung kag hemispherical kuan tank. Ingyan eh. So, ang imong cross-section dres imabaw is the greatest, mo naman ang siya ka gamay. So, there's a variation in your uh, cross-section. So, that's why you have to use this equation or kani. So, okay. Okay. So, last topic, 6 is the where. So, mo ni ang pinakadaghang formula. So, ang katong first na to nga mga topics discussion karon was to determine the flow in pipes. Pipes to tanan. Karon this is the flow in channel. So, open channel. Kana si kani. So, okay. So, mura ni siya inganig porma. So, kung nakakita mo sa kadtong ang sa tawa na where is flow. So, nakikita mo sa kanang sa irrigation nito sa na kanang itchon, imabaw sa itchon sa itong lugar. So, nga na example. Or pwede ka ni, ingani. So, this is the where. So, if what nang kuan, if what ning, kung sa tawa na, if what ning where, supposedly, constant flowing rin niya imong channel. Pero pag butang nimo sa where, there's an increase in elevation kay tungod sa imong gitawag nga hydrodynamics. Then that head nga sa pag-increase, that will be used in our solution. So there are classification of wares according to the shape. So it could be rectangular, triangular, trapezoidal, and circular or parabolic. So in trapezoidal, there's a regular Cipolleti wear and a non-regular trapezoidal wear. So there's okay. So contracted wear, crest of the wear is the top. So katong ganina, katong niya na the crest of the wear is kanina dire. So the overflowing stream in the wear, this is the knob. The contracted wear, this is contracted wear. Kay imong gipagamay siya. And this is equal to 0.1 H. Okay. Kana. So basta i-value ani ni dire is 0.1 H. So that is for contracted. For suppressed wear, if that is your open channel, igura ka nagbutang diha, that is your suppressed. So this one here is only good for rectangular nga wears. Okay? So sa rectangular na. Drop down curve, the downward curve of the liquid surface before the wear. So naman ay kuan, naman ay okay, nara. So if this is your wear, nara man di ay. So this is your nap. Okay. So head is the distance between the liquid surface and the crest of the wear. So mao ni imong head. Mao ni imong head. Gikan na jud dire padong dire. Okay? Dili ang entire depth sa tubig. Again, ang head dire sa wear that is only from the tip of the crest padong sa tip sa imong kuan dire. So nama kay drawdown. Drawdown is due to the head loss padong naman ubos. Okay, so more naman siguro. Okay. Okay. Okay, so diri na kay consider nga velocity approach kaning HV, that is your velocity approach. So mo na yung daghang memorization. So karon mo di man jud mo mag-memorize kay open notes man tanan nato exam. Pero usually sa board exam mo ni ang kinadaghan nag memorization kay every shape has its own formula. So example for this one, for the actual discharge of a rectangular wear, assuming that there is a velocity approach, it will become this one. Q is equal to 2/3 C squared of 2G times the length of the wear. So this is the length of the wear. If we are talking about the wear, the length of the wear, mao na. But if we are talking about the channel, it will become the width of the channel. Okay, di ba? Mura man na siya gingana. Di ba? This is your channel. So meaning this is the width of the channel. This is the length of the channel. But if we are talking about the wears, it is the length of the wears. So kani, if you're considering the velocity approach, kay naman kay velocity approach meaning na kay head sa velocity. Whereas if you are not considering the velocity approach, or if the ratio h over p is sufficiently small, so i-cancel ra na nimo ang kanang mga hb, so kani ang imong value. Where cw, kaning value sa cw is equal to kani. This is your cw. Or that is the coefficient of wear. So reminder, lain ang coefficient of wear o coefficient of discharge. Kay nara ang coefficient of discharge, di ba? Mao man ang coefficient of discharge. Ang coefficient of wear is 2/3 C squared of 2G. So that is your CW. Okay, so ang pangalan mo formula for contracted wear. So kani. Okay. So standard wear factor kato CW na kay Francis formula, Rebock and Chow, and the Bazin formula. So Francis formula, mao ni imong equation 1.84 times 1 plus 0.26 h over d squared. So if h over p is lesser than 0.4, unsa ning h o unsa ning p? Your h there is the head of the water, whereas the p is the head of the height of the wear. Okay? So kaning p dire sa equation, this is the height of the wear. If it is lesser than 0.4, then the value for SI or English is different, 1.84 and 3.33. Okay, so you have to memorize this. Kung sakto, kung napata sa kuan, classroom, mo na yung memorization. Napa, Rebock and Chow for English, and for SI, and also the Bazin formula. Kani. So, mas taas pa dyan ang formula ani, nagabot na to chapter 7. So, kani mo buo na lang nga formula kang Bazin. So, that is 0.5518 times the quantity of 3.248 plus 0.02161 over H. And also, this is for SI. Ang English, nasa usa ka libro. SI ra na siya. katong kang SCOM nga hydraulics nga libro katong gihatag last meeting na nga tong English nga formula unit. So again, you must not, if the given is English unit, you must not change that into SI or vice versa. Mo man yung gibuhat, so I will not check it. Sa kuan pa na kanang rongan dyan na masibaw sa una ni Pipino rongan ni. So 1N contraction and 2N contraction sa contracted rectangular weirs. So if you notice, the L prime is the actual L. So mana na imong L prime if it is contracted. So katong gingon ninyo nga 0.1 H, so sa usa ni kani this is 0.1 H. So kung duha na, so duha na ka 0.1 H. Okay? So na makay 2N or double contraction or double contracted or 1N or singular contraction or singular contracted. So mo ni. So kanay imong L nga gamiton nga equation. Okay? So daghan na kang memorize nun. So okay. Me. So for a triangular wear or a V-notch, so kani this is your theta. So nakailaing formula for 90 degrees nga angle o na po kailaing nga formula og less than or greater than 90 degrees. So ani nga formula, you are going to use ani Q is equal to 8 over 15 C square root of 2G tangent theta over 2H to the 5 halves. Where kani nga value mao na po di mo CW sa triangular kana. So katong wear factor, coefficient of wear. So mao na po na mo CW. So for standard 90 degrees kani imong gamiton nga formula 1.4 H to the 5 halves. Kung English 2.5 H to the 5 halves. Okay. So mo na imong equation nga gamiton. So basta kay mo ni ang equation nga gamiton kani. Kani si John, we are considering L pa man kani nga L. So which is na error. So usually kani may gamiton. Kay we are using triangular V-notch where man good. So trapezoidal, sharp-crested, actually you have only to add the rectangular section and the triangular section. So kana ra. So mora na siya. Ang namalahi ra is ang sa spaghetti wherein you must remember this one. Kaya uban yung problem nga moingon ra nga trapezoidal wear having a section 1H is to 4V. So, matik na siya nga Cipolleti wear. So, mo na imong gamiton nga equations. Okay? So, basta kay mayo na nga basta ka na kay actually Cipolleti wear is also a trapezoidal wear but the side slope, ang side slope is mo ni. Okay? The side slope is 1 horizontal to 4 vertical. So, mo na siya ang equation nga automatic. Di na ka mag-ingani. So, kani is the rectangular wear. If you take note the equation, CWLH to the 3 halves, and kani, di ba? CWH to the 5 halves. Kani. Kani. CW tangent theta. So, Z na isang gigamit dire, kaya kaning Z is, mao naman eh. Okay, so mao na sila. Okay, so kani for hyperbolic, di makuha kumukuha na sa birchware. Okay, sometimes. Unsteady, so same ra ni siya o formula sa katong orifice, pero lain na siya og application. Diri na pud ka sa diri na po ka mag-apply. Okay, so that ends chapter 6. So sa mga problems, kani, so ang answeran nga problems will be sa katong SCOM next meeting na naman. So ang akong gustong buhaton ang inyong buhaton karon nga week wa sa laman kay Semana Santa man. Pero if you have the time, please study this one, okay? Kay you need to study this because this is the what's the name? This will be needed if we go to chapter 7. Kani sa chapter 7. Okay, this is chapter 7. So mas daghan na ba ning formula? Then magamit pa jud to nga katong mga una nga na discuss nato. So again, na mao na gingon ninyo ganina nga orifice nga inclined. So this is your angle. So pwede ra ninyo studyhan katong ganina nga napoy lain-lain nga fluids, di ba? So this is application. Okay, so kung sa ito yung nakitaan, nakatunan sa una. So this one also, you have to add the head. So kung sa ito yung nakatunan sa chapter 2, na magbalik na dire. Okay, kung sa may na discuss. Okay, so na uban nga formula nga ihatag dire within the solution, pero I don't like nga inyo nang gamiton kay usually mas daghan na mo daang formula, for example kani daghan na mo formula daan nga gi-memorize, then dugangan pa ninyo nga pwede naman og if you know the basic, for example kani sibaw naman mo unsa ni this is manometer, this is kuan, so you don't need to memorize additional formula kay in board exam mas daghan kag formula, mas daghan kag makalimtan. So ang buhaton, you must know the basic kay mo naman ay kuan basta kay bawas basic makakuha makayani. So di ba? This is another solution. This is shorter, but the problem is, do you want to memorize this long equation formula? Whereas diri wa kay formula gigamit. Nga naman, Bernoulli's energy equation. Then chapter 2 katong manometer mao man eh. So Bernoulli's energy equation and the manometer, then you can get the answer. So kibali mga nakatunan ninyo sa inyong past nga klase. Whereas kung kani mag-additional kag equation. So na kay usa kay ngana napakailain ni ngani. So you will be in a disadvantage although shorter ang inyong solution kay right direct substitution man ka, but the problem is this formula will not be given in the board exam, so you need to memorize. Whereas kani look at this, wa kay memorize on. Basta kay baw ka sa basic sa Bernoulli's energy equation, kay baw ka sa basic sa pressure head, you don't need to memorize anything. So kibali di na ka mag-memorize ana. So clue di ay kung unsa to nga tubig or unsa to nga fluid nga nasa imong orifice. So for example, kani if kay this is water man, so meaning everything must be changed in terms of water. So kani, if you notice, but if this is mercury, then you have to change everything in terms of mercury, not water. Kung unsa to nga fluid nga nasa orifice or nasa opening, you have to convert everything into that fluid. For example, kung oil ne, i-convert na into oil, dili water. Okay? Kay mo na kasagarang kasipyatan. So for example, kanay glycerin, so look at this, it has been converted in terms of glycerin, not water. Okay? That is very important. Kaya mao dyan ay kasagaran nga karungan diri sa chapter 6. Then, so pa man. Kaya ini kakuan. Okay, so kani for example kani ito na i-discuss. Okay. Mara man siguro. Okay, I think question. Questions. Okay, where? Okay, so any question? So our next meeting will be, okay, so we will not meet next week because that is Black Saturday. So we will meet the week after that. So we will meet on April 10 for this one. So I will give you examples in chapter 6, then afterwards we will start in chapter 7. Then April 17 will be your IA 4, then IA 5 for April 24. Okay. Okay, so aside from that, mm, so na changes lagi sa schedule. Okay, our time will be changed next tomorrow. So we will move back by 1 hour. So from UTC 1, we are 7 hours. You are ahead of us 7 hours. So next week we will be ahead by 6 hours na lang. So there will be a time in the schedule. I will just tell you when our start of class will be. So I think it will be 3 p.m. or 5 p.m. So ato na may bawa next week. So aside from that, regarding the simulation, so I told you nga it will be a single PDF file. So most of you, I don't know if it's most, I'll check. So most of you submitted in document file. See? So I will not check those who submitted nga document file. Kaya ang problema lagi, nag-open ako ma-edit-edit. So it will be hard for me to check. So it will be much better if it is PDF kay di na siya mo lihok. So I think I also put it in the instruction that it will be a single PDF file. Okay, so I think that's all. So if you don't have any other questions, so thank you for coming. God bless. Bye-bye.
Thank you, sir.